All right. Sorry. So we're going to get kick-started here. My name is Brandon Palin. I'm the Senior Director for Public Sector and International Development at Ecopia. For those of you that don't know us, hopefully after today you'll have a bit better understanding of the work we're doing. So the title of this presentation is a little bit different from, it's still the same context, but effectively because I'm being followed by Mr. Eric Hunn here from NOAA, who's going to talk about some of the work we're doing on a national scale with them and their 1 meter data sets, I wanted to focus a lot more on the use cases and understand the value of high-res mapping data and why there's a greater push for it, why we need it, and what it's being used for. So that's why I've kind of shifted this a little bit more to the value of the high-res data to be a bit more informational. Thank you. So when we talk about geospatial data, I really like to think of what we're doing as being the foundation of innovation. You know, we talk about all of these initiatives nowadays, the term the digital twin. This is somewhat of a buzzword or topic, but ultimately speaking, the foundation for these elements is strong and true geospatial data. So, whether we're talking about, all of these sort of features that I'm popping up now, but ultimately this animation, it may not necessarily be a true reality, but in essence, these are the data sets that we are creating. And so this is kind of what Ecopia is supporting in the sense that we're extracting these buildings, we're extracting these 3D elements, we're understanding the tree canopies, the impervious surfaces, bike lanes, we're understanding transportation lanes to support pedestrian safety. All of these elements are critical to supporting the next generation of mapping tools. So a little bit about Ecopia. Ultimately speaking, Ecopia is a bit, relatively young company. We actually just had our official tenure, so to say, as being a commercialized company. But ultimately, the company started off effectively leveraging deep learning technologies to extract building footprints and extracting them on larger scales. So we started off doing that and commercialized in 2015. Through that, you can kind of see the progression of the technology on this slide. So the one thing to note is that when you talk about AI, deep learning, machine learning, all of these topics, it's important to know that you can't effectively achieve something overnight. You need to build a process. And with that, Ecopia has invested about $100 million in terms of research and development in terms of building our algorithms. So from those building footprints, what we did is we transitioned and built the technology up to a point where we started extracting land cover features. Then we started going into even more planimetric level detail. So more recently, we're supporting initiatives, those smart cities, transportation engineering, cool projects around autonomous mapping. But what I'm really excited about is the transition from data as a service to data as a product. And when we talk about data as a product, this is effectively the scope of the presentation today. And with that, effectively, is the concept of Ecopia having built out the first US nationwide 3D land cover map. So who's using these data sets? And it's important to understand that as we're creating this and as we're shifting this model from data as a service to data as a product, we're able to service a lot of different industries and use cases. And with that, we're able to build efficiencies in terms of, one, cost savings, but also in terms of how we can support our clients across the board and being able to provide them unique solutions. So whether we're talking about municipal or federal use cases, there's different data sets that I'll talk about that can be used across the spectrum. A little bit out of the scope, but I like to show this slide just to talk about the scale of data sets. So on the right-hand side, what you're seeing there is sub-Saharan Africa, and those are actually the building footprints that we extracted. That is not a map or a representation, that is the true data. Likewise, on the top left is Australia, and the bottom left, I think you guys would recognize that. That is the US. It just kind of puts things into perspective in terms of when we start talking about data and the location of people. How we're doing this, we're leveraging different input sources, ultimately aligning the input for a fit-for-purpose data set. When we talk about North America, we are extremely fortunate. There is abundant aerial capture. And so for us, what we are primarily leveraging in the US is the commercial imagery programs. With that, we are effectively able to leverage 6-inch to 12-inch aerial imagery, stereo aerial imagery to create our products across the board. We are also leveraging some of our client-provided imagery for project-specific work, but the primary goal of this is just to effectively kind of bring to the table that what we're doing is aligned to the data set that we're kind of leveraging to support it. So I'm not going to talk about this too much, but ultimately speaking, it's important to understand that it's not like we just upload this onto our servers and click a button and poof, you get a map. There's highly detailed levels, especially in terms of workflows and quality control parameters. And I'll talk about the quality control components a little bit, but ultimately speaking, there still needs to have that human component into these projects, especially as it comes to validating the products, the training data sets that are involved with those elements, and the iteration. So when we produce these data sets, we actually guarantee over 95% geometric precision. Ultimately, we consider our products to be equivalent, if not greater, than a GIS professional level accuracy. And that final output, I have vector-based information because that is the root information. In terms of some of the stuff we do for the federal side and the open data networks, that is effectively where we take our high resolution product and we transform it to a 1 meter raster product. So what does that product look like? So 3D land cover across the United States. So in terms of our input, like I said, commercial imagery sources, generally speaking, a lot of the data sets what we leveraged this time was Hexagon provided imagery, which is very much aligned to the NAEP program. There's also an injection of some of Excel's commercial imagery and some other, a few other products, but generally speaking, those are the scope. So that's where it's the 6 to 12 inch stereo aerial imagery. And then in Alaska, albeit it's definitely not to scale, Alaska, we leveraged a 50 centimeter ortho mosaic to be able to do that. So no 3D component in Alaska, but still pretty exciting. Recently there was some news, we provided all the building footprints to them to support their broadband challenge work there. And it's really exciting work that we're doing in terms of creating the first land cover map of, they're gonna get a full tree canopy layer, they're gonna get an open water body layer, impervious layer, and I'm sure Eric will be able to provide more detail on that in his presentation after. So these are the core features. And I say core features because it's important to understand that when we talk about land cover, there's a lot of different ways you can go. And there's a lot of different features you can extract. But what we find is this is effectively that base structure. And it hits 90% of the points, so to say. And we talk about the 3D component. 3D is a bit of a stretch in terms of the polygons themselves. We derive it in a 3D format. So using the stereo imagery, that's how we're able to create our own elevation products. But the height attribution is effectively a 2.5D polygon. The last thing that I'll point out from this slide, because I'm already a bit behind here, but is the tree canopy polygons are captured as a unique data set, unique data layer. So that means we're capturing the overlapping polygon in terms of the impervious surfaces, but then we also capture the true underlying impervious surface. So we're able to kind of provide the best of both worlds. And so that's when I talked about servicing multiple users with one product. We had to really think critically about how it would be best to go about doing that. So a little bit about the approach, just to kind of summarize things. Accuracy, that's where the 95% component is. We can talk about false positives, false negatives as well. Those are all less than 5%. The accuracy, I will say, is an interpretation accuracy measurement. As we're doing data extraction from commercial imagery provided to us, the absolute positional accuracy is dependent on that imagery. It's still extremely accurate for something on this scale. Normalized data, this is probably the most important thing I would bring to the table is when we talk about creating this product, we're not talking about one-time data creation. We're talking about sustainable data creation, which I think is probably the most overlooked item as it relates to geospatial data and the core component of making sure that you have to be able to update those data sets. What we see is, a lot of, whether it's state, federal, or even local users, their data sets, especially the land cover data sets, 10, 15 years old, sometimes 20 years old, because they had a one-time project to do it, but there was never the ability to maintain that. And so that's where we're trying to come in and support it. So why? A lot of people are trying to understand what is the why? What is the value of this? Why are you doing this? What are the use cases? And effectively, this ties into the equation of also, where is the funding? I think that's probably the number one question we get is, we love this data, we want this data, but how do we get it? How do we pay for it? And thankfully, we're in an extremely good position. Well, I shouldn't say we. with the US government releasing funds to the Infrastructure Act, Inflation Reduction Act, there is quite a bit of resources available, including some grants that I suspect, I'm not sure if Eric's going to speak to them, but there are quite a bit of grants flowing out of NOAA that can support this data development. So why? Impervious surfaces. I think this is a pretty evident one. It also relates in terms of the previous presentation as we talked about the 3DEP program and the elevation products. But ultimately what we're seeing is, with urban sprawl, urban growth, natural pollutants affecting natural water bodies across not just the US, the world. And with that, it's very important to understand where they are at. And thank you. That is one of the core components that we realize. As a primary example, recently we were working with Texas. And in a county, 13 counties, they had 13,000 miles of roads mapped, but the actual census was 33,000 miles. So that's a grave discrepancy in terms of impervious surfaces and the water flows from that. Other elements, coastline, storm surges. I think this is extremely relevant, especially being in North Carolina. What we're seeing is population shift from those coastlines and move more inland. And with that, you have a changing natural landscape. So leveraging some of these existing for even flood maps or understanding where population points are, it's critical to have an updated data set. And so building off of that is the next equation of extreme heat and urban heat islands. And this actually kind of speaks to the concepts of also the digital divide or digital equity, and addressing those most vulnerable populations. So what we find is that impervious surfaces are highest in terms of areas with lower incomes, and we're seeing tree canopies be the lowest density in those areas as well. And there's a direct correlation actually to deaths. So having that background information is critical in terms of planning and supporting, in addition to everything else that you're seeing on here. So now I wanted to dive into a little bit deeper, and I actually I created some North Carolina specific slides. So if anyone's from around here, I suspect that is the case, but ultimately speaking, this is kind of how we're trying to support the local community. So population growth, around 10% over a 10-year period. With that, you can imagine the requirements from an urban planning perspective. 10% equates to significant changes of not just infrastructure on the public side, but also private infrastructure, development, homes, whatnot. And with that, you have to deal with these elements, the flooding risk, excessive heat risk, and wildfire risks. So understanding where populations are, where people are, understanding evacuation routes, all of those elements are critical to public safety. Additional environmental challenges, the clean energy. So in 2018, over 81% of North Carolina's total gross emissions were fossil fuels. As these initiatives that are tied to funding are actually a lot correlated to this and being able to demonstrate positive change. So how are you able to demonstrate that change if you don't have an existing data set to show improvements? This is where it's extremely critical to have these core components. Department of Transportation, ultimately this is just large-scale data creation, large-scale data maintenance. It's effectively, I gave that example previously about the Texas scenario where, they just haven't updated their inventories. The local teams probably have, local, regional, but then the data aggregation becomes also a bigger challenge because you have different data sets compiled in different ways. And that's why you need to think about these problems on a big picture basis. And with that, kind of builds towards Ecopia's approach. So I like to think of what we're doing as aligning our geosolutions in a way that's going to drive economic and social impact. And by kind of bringing those two elements together, you're able to explain to people, even who may not have a geospatial background, the value of this. So as I said at the start of this, one of the things that we always try to think about before we start large scale or even small scale projects is stage 3 there, which is the maintenance. It's very important to go about a project understanding not just how we're going to get things kicked off, how we're going to create it, how it's going to be the most efficient, but how, whether it's 1 year, 2 years, 3 years, or even 5 years down the road, you're going to be able to maintain that data set. And that's a big reason why our data set is aligned so well with the NOAA CCAP program, because CCAP, Coastal Change Analysis Program, it's about data creation in a sustainable way so that you can understand the changes and impacts with that. So ultimately what we're bringing to bringing to the table, I should say, is that flexibility, that feedback, and that data optimization that enables us to maintain and keep things updated. So a couple of case studies here. I got about 5 minutes, so I'm going to streamline through these. But I wanted to give some examples on both a local level and a state level of how people are using our data sets. So the city of Detroit came to us in 2018, and they had started creating their own impervious data layers. They were doing effectively planimetric level data extraction across the city. A big reason for this was all of these items that you can see here, but ultimately speaking, it was the root of it was to power their stormwater utility fee, or their drainage fee as they call it. But the manual heads-up digitization approach was proving to be, one, extremely expensive, and two, the results they were getting after that year one kind of initial data creation, there was a lot of interpretation error. As when you start talking about more complex projects and more detailed and granular work, you run into that issue a lot, because if you have a lot of people digitizing, some people are going to make some mistakes. It's just the nature of it. So having a rules-based data extraction approach, like effectively what Ecopia is doing with the AI methodology, is critical to that. So anyways, we worked with them. We built out this scope in terms of identifying what features were most critical to them, how did they want it done in terms of understanding, paved, unpaved features, natural categories, but more importantly, how could we maintain that data set, guaranteeing consistent and uniform data creation. So what was the kind of takeaway from that? So traditionally, when they were doing this methodology, their imagery was captured, and by the time they were getting their data sets, I say 14 to 18, it was really on the later end of that spectrum. They'd get their data sets 18 months later. So the reason why this is a huge problem, especially if you're using this data set to bill your constituents, is that there's a significant amount of change that happens within a year, especially in a municipal area. And I'll show that in a second. But ultimately, what our solution was able to do here was deliver results to them 4 weeks after they received imagery. And that is a standard for us on our local scale, as we still, as I mentioned, working both municipal, state, federal level. But when we work on the municipal side and county side, our turnaround time for data deliveries is 4 to 6 weeks. It doesn't matter about the size of the county or municipality. That's could be the largest city, like New York City, or it could be a rural area. That's just kind of the set and foundation. So the takeaways from this, and I talked about that change. So the average change since that we've been doing this, we have a multi-year contract with them since 2018. It was just sole source renewed till 2025. But what we found was an average rate of change of about 2% a year, which is a discrepancy of about $5.6 million in terms of their stormwater utility fee. Some formatting there. I think that's because of transferring this computer, if that's okay. But the one thing I want to highlight from this slide is the way that we look about these projects and the work that we're doing is shifting beyond just a data provider. We're a data partner. And that's clear in terms of what Dan Rainey, their Chief Information Officer, said there, being able to be a partner to the Detroit Water and Sewers Department. These are just some of the photos to give an idea. I think this photo may be in your slide deck, but I'm not sure. But this is Detroit. This is that single layer impervious, and this is what we were able to provide in terms of the granular level details, unpaved, paved surfaces. I know I'm running low on time. We may go into a bit into questions. That's okay. But from the success of this, actually, they received additional money from the city because they were able to see the reward of this. And now we're producing a 25-layer, effectively planimetric level detail map for them on an annual basis. So that's super exciting. The last one I'm going to highlight here very briefly is the work that we're doing for the Illinois DOT and CMAP. So this is more polyline work. So this is actually deriving the data where you're talking about actually providing information, crosswalks, each individual laneways, medians. So the use cases for this, ADA compliance, pedestrian safety, city planning, you name it. And this is actually a cross collaboration that we had 3 organizations involved with. So 3 organizations that are all getting data sets on all different layers of government. I think it's a fantastic success story that demonstrates collaboration and what can be possible when you talk about data in an open forum. So yeah, this is effectively the scope of that project. As you can see, ADA compliance support, there was funding there. Similar funding is actually available in North Carolina amongst actually in every single state. 26 land covers and also the polyline data set. So super exciting stuff. This is just a little bit of an example that shows those polylines and actually the street trees. There's also a street canopy there. But yes, I'm out of time. So with that, are there any questions that I can help answer about some of the land cover work? I did want to say that there will be another presentation right after this in terms of the work we are doing at the federal level and the great work that NOAA is doing for the Digital Coast program. So if there's any questions related to that, they'd probably be answered then. But otherwise, thank you very much. Sure. Yeah, we have building footprints derived for the entire country. So we update our building footprints on an annual basis. So we have 172 million building footprints across the U.S. that are all structure coded with geocodes. Actually, it's being used quite a bit across the spectrum for broadband challenges right now. So for example, Michigan is using our data sets, Oklahoma is using the data sets, Kentucky's using the data sets, Arizona, and Alaska. You just have to talk to me. That could be something that could be easily coordinated. I know Tim and I have been discussing that as well in the past, but we have the 2D data set ready to go alongside perhaps the 2.5D product if that's requested. Any other questions? Sure. Yeah. You know, I'll say one of the challenges that we face is Ecopia is, like I said, a relatively younger company in the spectrum of data creation. A lot of our work that we've done, so even the work that we do on the federal side is run through the primes that are on the CGSC4 contract. So we partner with a lot of different agencies. I see Bill Johnson in the back there. He's actually, we funnel a lot of the broadband work, for example, in terms of their leveraging the building footprints through that. The primes that are involved with the NOAA work, Wolpert, Dewberry, Tetra Tech, NV5, data flows through them. So one of the primary things that we're working on is educating people on what's available. So that's part of the reason why we're having these conversations. Say, you know, a lot of people actually haven't heard of this or haven't heard of the work that we're doing. And with that, it's very important to be able to engage them and tell them where they can have access to this information. Any other questions? Yeah. Yes, they are. Insurance companies have as well. There's a significant improvement in terms of both currency of the data set, completion, accuracy. I will say, like, the Bing data set from an educational standpoint and effectively that standalone data set as a free data set is fantastic. You know, it's a good piece of information. However, for critical decision making and planning, you'll notice there's a significant gap, especially in a lot more rural communities or communities that are recently built within the last 5 years. That's where you can see kind of the discrepancy. I don't want to give you a statistic in terms of what the delta is because it really varies on a state-by-state basis. But I'd be happy to provide some more information if you had any questions about that. Any other questions? I thought I saw one. Oh, yeah. So the competitive landscape of the industry is broad. I'd say ultimately when we talk about this national level product, there really isn't anyone doing what we're doing at this level. We've seen others create data sets purely at the 1 meter level using open source imagery, but doing this data creation off of the Stereo product, it hasn't come to market. On a local level, there's a lot of different groups that are doing data creation, supporting local organizations, local municipalities. We see a lot of groups that are involved with that in terms of, and some are deploying some AI strategies. The Esri strategies, the AI tools that are built into there, but the results just aren't necessarily standardized, especially as you start talking about larger areas. So we find a lot of clients come to us after they've tried a different approach or an existing approach that they had, and then say, hey, can you guys help us? Because we're noticing that we're spending more time trying to fix it than we did create it. I'm out of time here, give or take. Maybe if there's one last question, I don't think so though. Great. Thank you guys all so much. There's my email. If you have any other questions, happy to answer it. Otherwise, I will pass it off to Mr. Hun from NOAA. Thank you very much.